here. So why do we need to classify the elements? So what is the purpose? So what is the purpose of classifying? What is the purpose of classification? Classifying the elements. Classifying the elements. What is the purpose? Why we arrange the elements into groups, or we should classify them? What is the purpose? Anyone?
So please change the color, sir. It's not visible.
Not visible.
Yes, sir.
ठीक है.
Mine its properties.
Okay, I will go for this. Is it visible now? Acha.
Yes, sir.
Sketch color is not visible, na?
Yes, sir.
Okay, then I will choose black color
Sir,
one.
don't change the background.
Okay, right. So now coming to the point is of course now is it visible to you now? Why do we need to classify the elements? Why do we need to classify the elements? So the purpose, see, this is black is required, I think. The purpose of, is it visible now?
Yes, sir.
Classifying elements. So classifying elements, the purpose. Okay, I will, let me take black is, where is the black? Now, yes, predict the reasons. Means why do we need to classify the elements? Number one, can anyone guess? So see, studying 118 elements causes confusion. What we say, it causes chaos, right? Confusion. And studying about their compounds. See, studying 118 elements, their properties causes, so what we say, chaos and confusion. And again, studying their compounds. How many compounds are there? Millions of compounds are there. So, and imagine how much time it will take for studying. So, how much time it will take for study of the compounds of elements. Compounds of elements, how much time it will take, imagine. That means here, in order to overcome the confusion and chaos, or what we say, and to study the compounds of elements in systematic manner, so we need to organize the elements, we need to organize the elements we have to organize in systematic manner so that their study would become very easy. That means we need to group the elements, we need to group the elements, we need to arrange the elements in systematic manner so that our study becomes easy, and in less time we'll get more information we get about the elements and also their compounds also easy for us. So this is the purpose. That means time saving. Number 2, easy to learn. Easy to learn about the elements and their compounds systematically by organizing the knowledge. Okay, so it is like example I'm giving. Why do we need to classify the elements? For example, imagine our library. Library is there. If I ask you one book, the chemistry book, one book name is Madan and Tuli. One book is there. So this book, which book this is? Inorganic chemistry, for example. Inorganic chemistry book, if I mention. So if I tell this work to one student, so bring this book from the library. So if I give permission him to go into the library, pick up this Madan and Tuli inorganic book. So in that library, huge library, there are so many books will be present. Then, so in case the student having knowledge about the library, where the chemistry books are kept, where the bio books are kept, where the type of physics, all that. So directly, so the student will go to the library and he will go to the chemistry part, and in that chemistry part there is inorganic part. In that place, easily will pick up that book and will come back. But imagine if the books, all the books, bio, physics, chemistry, all the books are kept randomly, no organizing, no systematic. All the books are kept randomly, mixed up. Does a student bring that inorganic chemistry book within the stipulated time? Does the student bring the book? See, earlier, so since the student aware of that division of the books based on the branches in the science, easily will pick that book within 5 minutes or within 2-3 minutes. Okay, within a few minutes. But the books are kept randomly, without organization, systematically. If you ask the student to pick that inorganic chemistry, some other book, it is quite difficult. And it will take 1 hour, it will take even 2 hours also. Time consuming and confusion also. That means here, if you want to make the things easier, we should keep all the books as per the branch wise. As per the branch wise, we have to put the books, okay, so that our picking will become easy. The same manner, elements also. There are 118 elements are there, 100 elements. If you want to learn randomly means it is quite challenging for you. Quite difficult for you. It causes chaos and confusion. So to learn about the elements, if you go systematically, step by step, becomes easier for you. That is the need and that is the purpose of classification of elements. Right, now I am moving further in this topic. So after this, that means here the large number of elements, it is very difficult to study individually the chemistry of all these elements and their innumerable compounds individually. To ease out this problem, scientists searched for a systematic way to organize their knowledge by classifying the elements. Not only that, it would rationalize known chemical facts about the elements, but even predict new ones undertaking further study. Now, the concept of grouping elements in accordance to their properties led to the development of periodic table. So that means here the periodic table concept, idea of the periodic table came in the concept of grouping of the elements according to their properties. That means elements and their properties. That means based on the properties of elements, grouping has been started. The grouping of elements based on their similarities and dissimilarities of their properties What has come up means the periodic table has come up. Periodic table. Periodic table has come up. So now we are going for the discussion of genesis of periodic table. So means how the periodic table has come up. So now we are going to discuss about the history of classification of classification of elements we have to study now. The classification of elements into groups and development of periodic table are the consequence of systematizing the knowledge gained by a number of scientists through their observations and experiment. Now look at this picture. Now look at this, the history of the periodic table. The first time, so one scientist, alchemist, the periodic means alchemist. So that scientist means not scientist, we say alchemist, we say history of the periodic table. The first person in a recorded history to observe or to discover a new element was, you must note down this scientist. See, this is not there in syllabus, but I am taking Henning Brand, one scientist, one philosopher, a German merchant. So he tried to discover philosopher's stone, mythical object that was supposed to turn inexpensive base metals into the gold. Alchemist, we say. So, and for that he was doing experiments, and with the distillation of human urine, he was keep on boiling the human urine, and finally what he could got means a glowing white substance he got. So which was called at that time phosphorus element. Cold fire he got that time, but he kept a secret, that cold fire experiment, not disclosed, not revealed to anyone. That means indirectly, so by trial and error, he prepared the time, so prepared the phosphorus element, but he couldn't study the properties and he couldn't tell about what kind of element that was. So he kept his experiment secret for so many years, so without disclosing to anyone. And later, one scientist, Robert Boyle, was a scientist who discovered that same element, phosphorus, and published his findings. So the discovery of phosphorus helped to raise the questions of what it means for substance to be element. So that means Robert Boyle described that properties of the phosphorus in elemental way. So even the Robert Boyle also could not describe what properties of the element should have. So he couldn't explain. Then, so after that, in 1789, French scientist Anthony Lavoisier described what is meant by an element. So, and Lavoisier was a scientist who described the element and who defined the element also. Lavoisier scientist. So Anthony Lavoisier defined element as a substance whose smallest units cannot be broken down into simpler substance. Okay, and Lavoisier description of elements lacks some completeness. That means Lavoisier classified the elements into two categories. One is metals and non-metals. So discovered at that time, very few metals and very few non-metals discovered at that time only included the classification, and he ignored the metalloids in the classification. Ignored metalloids. Some elements having both metals and non-metals characters also, and so he couldn't classify the metalloids, only classified the metals and non-metals. That's why Lavoisier classification was incomplete, and but first he tried to define the element at the first time Lavoisier scientist. Lavoisier scientist. So after that, the scientific experiments conducted by the scientist John Dalton, already aware of this John Dalton scientist. So, and with scientific calculations of atomic weights of the elements he did. So based on stoichiometric measurements, along with this Dalton, so Dalton scientist, one more, Proust also scientist. So these two scientists totally means these two scientists calculated the atomic weights of the elements based on the stoichiometric proportions. Based on the stoichiometric proportions, so these scientists totally so did experiments in calculation of atomic weights so of the elements atomic weights. So first time calculated by scientifically by Dalton and Proust scientist. So then they got the data of the elements, so atomic weights they got from the Dalton scientist and Proust scientist. So in the 18th century, beginning of 18th century. So and this was the elements, list of the elements published by the Dalton scientist. So he has given the symbols of the hydrogen and azode. Azode means nitrogen, carbon, oxygen symbol, phosphorus, sulfur, like that. And their atomic weights also he has mentioned that time. Dalton scientist. So after the Dalton scientist, next to authentic scientific classification of elements. So here next what we have to discuss about here, very important classification. So this is there in your syllabus. So that classification means early classification of elements done by the scientist, name of the scientist, Doberner scientist. So Doberner scientist, he was a scientist who made attempt to classify the elements. So around that time, so number of elements, more than 60 elements was found, and these elements so classified. So he classified based on what means so properties of elements, particularly atomic masses. See, atomic masses known that time because of Dalton effort, Dalton Proust scientist. So atomic masses and atomic weights known that time, atomic weights known to the Doberner scientist. So based on the atomic masses and atomic weights, so elements were classified into, means Doberner tried to classify the elements into groups. So groups based on what means properties and atomic weights. So simply on physical properties, particularly on physical properties of elements. So properties of physical and chemical properties of elements into groups. That means as per the Doberner scientist, elements should have similar characters, similar properties. So then only such elements are included in the group. A group should have similar characters, similar characteristic properties, whether physical or chemical, whatever it may be. And so in that means he selected the group of elements. How many? 3 elements he took. How many elements he took to make the group? So 3 elements, and he called them as triad. He called them as triad, we say. So triad elements. That means a group should have 3 elements, and those 3 elements should have similar properties, and these elements should be arranged increasing order of their atomic weights, increasing order of their atomic weights, we say, atomic weights. And one of the logical concept so arranged by this scientist, Doberner scientist, in his classification, so that is arithmetic mean. That means first time the logical classification, scientific classification was done by the scientist, Doberner scientist. That means so Doberner was a scientist who classified the elements based on the concept law of triad. This is important to you. So what is law of triad means? The law of triad, if the elements are arranged, if the elements are arranged, so arrangement is made if the elements are arranged in increasing order of their order of their atomic, see that time atomic number was not there, atomic weights. How the class arranged the elements? Atomic weights. So if the elements arranged increasing order of the atomic weights such that the arithmetic mean of first and third element was the atomic weight of the second element. So let me take one example. So I'm taking example, what does it means? So lithium I'm taking, sodium I'm taking, potassium I'm taking. Now can anybody tell atomic weight of the lithium? Atomic weight of the lithium. Are you listening to me, everyone? Yes, all of you.
Yes, sir.
Lithium, sodium, potassium, three elements have taken. Atomic weight of the lithium how much? Atomic weight is 7. Potassium is how much? 39. So 39 plus, I am doing addition now. 39 plus 7, how much? If I do average, 46 upon 2. So then I will get 23 is the average number. This is the average, no? Average mass. 23 is the mass number of sodium, no? Atomic weight of the sodium. Got it? Okay, so that means here, according to law of triad means, see, this was the classification made by Doberner scientist. In that classification, what he did means he grouped the elements. He made the group based on similar properties. Similar property maybe, so physical property you should take, or chemical property you should take, similar properties. And in that group, how many elements were taken by the scientist? 3 elements he took. So how we arranged the 3 elements? Increasing order of atomic weights, 7, 23, 39. So this is the increasing order, no? 7, 23, 39, increasing order of atomic weight, such that the first element and second element, if you do arithmetic mean, you will get the atomic weight of the second element. समझ में आ रहा सबको what I am talking about here? So how the Doberner classified the elements known to him at that time. So how many? There were only few elements, around above 60, around 63 elements, chemical elements were present. The 63 chemical elements known to him classified into groups based on similar physical and chemical properties. And in that group, how many elements he took means only 3. And those 3 elements, how we could arrange means increasing order of their atomic masses. Atomic masses he could arrange such that, so the arrangement also was logical. What was the logic here means? The first element, third element, atomic weight, if you add, do the average, you will get the arithmetic mean of second element. This was the classification done by the scientist. Clear?
Yes, sir.
Yes.
So this and that means the law means the principle involved in this classification by the Doberner scientist. The principle involved was law of triad. Triad means three elements. So how the three elements arranged means, so arranged increasing order of their atomic weights, because atomic weights known that time because of Dalton and because of Proust scientists, they give the atomic weights of the elements. Okay, atomic weights were given by Dalton, Proust scientists. That's why so the Doberner classified the elements very easily that time. But so this law of triad was not successful. Law of triad classification was not successful. Why it was not successful means, so now I'll take example. So what example I will take means, see, so one more I'm giving law of triad, chlorine, bromine, iodine. Okay, chlorine atomic number how much? Atomic mass how much? So 35.5 mass number. For example, bromine we don't know. Iodine is how much? It was 127 point something, 127 I am taking. So now this will make one triad. Because so why these elements are said to be triad means, so these are halogens. These are halogens. Their valency 1, their valency 1. This is similarity. They are gases and they are electronegative. So their valency is -1, means their valence is 1, we can say. They are the gases, so they are non-metals. All these properties, no, similar properties, they are non-metals. Got it? They are non-metals, they have valency 1. So these are the similarities. So now what I am doing, so is that arithmetic mean is applicable or not, we'll check. Arithmetic mean. So arithmetic mean, so we will check now. Arithmetic mean of these elements, chlorine 35.5 plus how much? 127 upon 2. What you will get? Tell me now. So 127, 35.5. So how much? 5 you will get. So then 2 you will get. Okay. And here is 4, 5, 6. So 162.5 upon how much you'll get? 2 you'll get. So then around how much? So 80. So around 82. 81 point. That means the bromium atomic mass was 81. So then we got 81. That means increasing order followed 35, 81, 127. Increasing order, atomic weight increasing order. Then 3 are similar, 3 having the same properties, that's why same group. So this was the classification, but so the law of triad, if you start to apply this law of triad system, if you apply to all elements, for all the elements if you apply, particularly transition elements like nickel and chromium, molybdenum. So this law of triad system is not applicable, not successful. Reason I'll tell. For example, simple example I'll take. There is nitrogen, carbon, nitrogen, oxygen. Okay, carbon atomic mass how much? Mass of the carbon atom how much? 12. Oxygen 16. 12 plus 16 how much? By 2 how much you'll be getting? 8. 28 upon 2. 1, 4. You got the 14 mass.
Sir, 14 will.
14 means atomic mass. Yes, IA. That this is right. So 12, 14, 16, right, increasing order of atomic mass, nitrogen atomic mass. But now properties I am checking, properties of these elements. So properties of these elements, carbon valency 4, nitrogen valency 3, oxygen valency 2. Valence is not matching, no? A group means a triad should have the same property, right? A triad should have the same property, but valency is differing. Carbon is the solid, nitrogen is the gas, oxygen is the gas. So some properties are not matching. That means here, if you start applying critically, so this lab triad system, so and we can get maybe sometimes with arithmetic means, sometimes may not get, and the properties matching may not be matching also. So that's why means Dobernet could not succeed in application of law triad system for all the elements. All the elements, not it was not successful. So that's why the law triad system failed. This classification completely not agreed. But he has given some one logical sense of classification of elements based on the atomic weights, based on the properties. He has given some one logical idea how to classify the elements. That's why Dobener classification is important discussion for the classification of elements. So you can try these chlorine, bromine, iodine, lab triad, calcium, strontium, barium, sulfur, selenium, tellurium, lithium, sodium, potassium. Now I'm moving further of the classification. After this Dobener triad, next to classification. So this is not there in your class, in your syllabus, but just I'll brief this one. A French geologist, Alexander Emile, so D. Chan Cortiasis. So here it is T is mistaken. So Chan Cortias noticed that the elements, when ordered by their atomic weights, displayed similar properties at regular intervals. In 1862, he devised a three-dimensional chart named telluric helix after the element tellurium, which fell near the center of his diagram. So now look at this diagram. So and in this diagram, he arranged the elements in spiral order. So three-dimensional chart, spiral order. So when he started arranging the elements, lithium, beryllium, boron, carbon, nitrogen, oxygen, fluorine, sodium, like this, in the form of spiral arrangement. So when he made the elements, arranged the elements in the spiral arrangement. So like this. The spiral arrangement like this. So here at the on the sides means here what he got means, so lithium, sodium, potassium, these elements having the similar properties. So the similar properties he got on the same line, and next to line he got beryllium, magnesium, calcium. So he got that elements which have the same property, boron, aluminium, and so he got here the same elements having the same properties he got. Carbon, silicon, titanium, you got the same properties element. So that means at regular intervals, you got the elements that having same properties. Same properties. See, you can see carbon, silicon, titanium. So these elements having the same properties came on the same line after regular intervals. It was noticed by the scientists, but this classification not that much significant that time. But one thing it was clear: properties repeated after regular intervals. Same properties repeated at regular intervals. He got this one. Regular intervals he got, which was later called periodicity. Periodicity first time noticed by this scientist because of spiral arrangement of the elements. So this is there. This is not there in your syllabus. Don't worry. Just for that classification I took. So the next one is with the elements arranged in spiral on a cylinder by order of increasing atomic weights. D. Chan-Cortiasis saw that elements with similar properties lined up vertically. So, and this classification not that much successful, but from this classification, what we can get that point means the elements are arranged spirally or systematically increasing order of their atomic weights. So properties, same properties repeated at regular intervals. That was the concept came. So after this, scientists very important. This is there in your syllabus. The next attempt was made 1864 by British chemist John Newland scientist. You should take the scientist Newland scientist. Actually, his name Alexander Johansson Alexander Rena Newland, the scientist name. So, and at the time of the scientist also there were around 62, 63 elements were present, and based on the trends, physical properties of the elements and atomic weights, means mass number, he made the classification. He produced a classification of elements into how many groups? 8 groups, where Dobner groups were triad groups. So triad groups, many number. So, but here Newland classification, elements classified into how many groups? 8 groups he classified. And Newland liked these progressions to the progression notes up with the musical scale, musical notes. This classification similar to musical system. Musical system. So I'll explain how this is similar to musical system, and it is the major principle involved in this Newland was the law of octaves. Law of octaves. So based on the concept, based on the idea or principle, what we call means law of octaves we say. So what is the law of octaves? Now I will explain now. See, at the time of Newland scientists, see first, so now I am going to discuss about, this is the very important classification. So Newland classification of elements. See, at the time of Newland also atomic number was not proposed. No atomic number, only what was there? Atomic weight was there. Atomic weight was there. And so they knew only few physical properties, not all physical properties and chemical properties. They knew about the elements. They knew about atomic weights, physical and chemical properties. So how many elements were present that time? So at the time of Newland, there were no noble gases were not there. Noble gases were absent, means not discovered that time. At the time of Newland, what elements were there? Hydrogen was there, lithium was there, hydrogen, lithium, beryllium, boron. Okay. డబ్బులు ఇచ్చేసే వాళ్ళకి. So hydrogen, lithium, beryllium, boron, carbon was there, nitrogen was there, oxygen, fluorine was there. There was no neon gas. Sodium element was there that time. So magnesium was there, aluminum was there, and so silicon. Then after silicon, after phosphorus was there. Phosphorus after, so sulfur, and argon was not there. So potassium was there, calcium was there. These were the elements. And he arranged these elements based on increasing order of atomic weight. So how we could arrange? 1, 7, and beryllium how much? 9, 11, 12, 14, 16, 19, 23, 24, 27, 28, 31, 32, 39, 40. So means these are the atomic weights. So how I wrote these atomic weights? Increasing order, decreasing order? Increasing.
Increasing order.
Increasing order of atomic weights. So written by Newland scientist. Which elements were absent that time? Noble gases.
Sir, noble
gases. No, absent. Noble gases were absent. No noble gases. Clear, everyone? Now, so he made arrangement, means he arranged the elements, he grouped the elements. For example, such that Indian musical note. What is the Indian musical note, for example? I am telling. So musical system is rhythm. What is the rhythm? Sa. Re, ga, ma,
Ga. Ma.
pa, da, ni, sa. See, now you can check this same rhythm, sa, and repeated again after 8th interval. So, sa, re, ga, ma, pa, da, ni, sa. So, first interval, this one. After 8 intervals, here you will get same rhythm, no? That means here hydrogen. So, the properties of hydrogen can be seen where in the fluorine, according to Newland scientist. Similarly, the properties of lithium can be noticed where means same properties noticed in the sodium. The properties of beryllium can be noticed where means in the magnesium after how many intervals? 8 intervals. Octet intervals. Clear, everyone? So that means the same properties,
Yes, sir.
same physical and chemical properties, same physical and chemical properties. So chemical properties can be noticed. How many intervals? 8 intervals. 8 intervals. That's why this law, what we call means law of octa. Octa means what? 8 octaves. That means at the first time scientifically the periodicity, what is the periodicity noticed by the scientist, periodicity noticed by the scientist, Newland scientist. First time periodicity property was noticed by the Newland scientist among the elements. So that's why what the Newland has taken, he grouped the elements, for example, hydrogen, fluorine, chlorine, one group, lithium, sodium, potassium, so another group, beryllium and magnesium, calcium, one group. See, now check between the beryllium and magnesium, how many elements are there? Beryllium 1, so 8th element is the magnesium. After magnesium, see, now you can see magnesium after, so aluminium, silicon, phosphorus, sulfur, potassium. So which element? Calcium. Calcium is quite similar to magnesium. Magnesium is quite similar to calcium in all the properties. So 8 intervals after. Now aluminium is similar to which element, can you guess? Scandium. Understood, everyone?
Yes, sir.
So this was the classification made by the Newland scientist. So this classification based on what? Law of octaves. Based on what means? So law of octaves. Octa means how much? 8. That means for every 8 intervals. So what we notice? Similar properties will notice. Similar properties will notice. similar properties we notice after 8 intervals. It was called periodicity. Periodicity by the scientist, Newland scientist. When the elements are arranged, if the elements are arranged increasing of what? Atomic weights. If you arrange the elements increasing order of atomic weights. Okay, not atomic numbers. No atomic number was discovered that time. No atomic number. Then, so was this classification successful that time? Means no. So what was the defect of this classification? So defect of this Newland classification, defect. Can you guess? So here the Newland classification was failed because of discovery of noble gas elements. Later, after this Newland scientist, so noble gases like helium, neon, argon, krypton. So these gases discovered by the scientist. So when these elements discovered by the scientist, the pattern of arrangement would changes. For example, hydrogen and helium, next lithium, beryllium, boron, carbon, nitrogen, oxygen, fluorine after neon here, again neon will come. Now look at this. If the hydrogen first element, second, third, fourth, fifth, sixth element, seventh element, eighth element. So hydrogen, earlier it was with fluorine, but now hydrogen is similar to oxygen. It is quite different because oxygen valence is 2, hydrogen valence is 1, not different, not matching. Noble gas is matching with the fluorine. Noble gas is unreactive, fluorine is more reactive, no way related. That means when the noble gas elements were discovered and arranged in the series of Newland concept, the law of octave. So the law of octave was not getting. Law of octave completely not possible. Means, so because of this Newland concept, Newland classification of elements failed because of the discovery of the noble gas elements. Clear everyone? Any doubt from this? Law of octave system understood? So for the
Yes,
law of octaves, we should keep the elements. Elements must be arranged. Elements must be arranged in what order? Increasing order of their atomic weights. Atomic weights we should keep. And such that the first element should have the similar properties with eighth element. How we should arrange the elements? We should arrange the elements systematically, increasing order of their atomic weights, such that the first element should have the same properties with the eighth. Hydrogen with fluorine, lithium with sodium, and sodium with potassium, like that. So this is the classification of Newland classification of elements. So the purpose of classification is arrange the elements systematically, systematic order for easy study. See, the outcome of this Newland concept was periodicity. Periodicity. He got the periodicity. Means, what is the periodicity? Means the recurrence of recurrence means repetition. Recurrence of physical and chemical properties at regular intervals. At regular intervals is called periodicity. Definition is clear, everyone? Or the repetition of the physical and chemical properties at regular intervals. Regular intervals is called periodicity. The first time the periodicity, so scientifically demonstrated by the Newland scientist, based on the law called law of octaves. What is that? What was the law? Law of octaves.